welcome back, guys. I don't even want to waste any time because we were so busy with some awesome question, and I know already you guys are sitting on the edge of your seats just waiting to hear what Heather still has in store for you. Make sure that during this segment you are even more focused than before, because the stuff that you learn during revision is absolutely fantastic, because these are the kind of things that you'll need to pass. Hey, Heather.
Absolutely. You learn fast.
You learn.
Okay, I hope that they're also learning fast. Okay, so guys, just before the break, we said that to find the point of inflection, there's two methods. My preferred method is the second derivative set equal to naught, and that gives you your x value. But as I said, it's definitely halfway between the x coordinates of your turning points. And so the alternative method is to take your one x coordinate of your left-hand turning point, add it to the x coordinate of your right-hand turning point, and divide it by 2. And of course, if you just do the actual mathematics of that, then you land up with exactly the same answer down here of 5/6. Okay, the last question of this segment is I want us to be able to write down the values of x for which f dash x is less than naught. Now, so many candidates battle with this because they don't actually understand the notation. All right, so they are actually asking you, when is the gradient or the slope less than naught? So in other words, negative. All right, now what you need to do really is to take your ruler and a different color, all right? And to understand that if you were to draw the tangent anywhere along there, it's going to look different to if you were to do it at the turning point. It's going to be different if you were to do it along this area, then again at the turning point, and then again down this area. Now, how do we describe how the gradient is changing? Well, definitely at the turning point, we have said that our gradient is 0, all right? That is at the turning point. Now here, this is the straight line, and one of the things that you first learned in grade 9 is that this straight line has a gradient which is negative, right? This piece here is a straight line, and your gradient is positive, all right? It's climbing upwards. As x is increasing, the y is increasing. And this one here again, your gradient is negative at the turning point, and here again, your gradient is negative. So they want us, when is the gradient negative? And so you can see that that's very, very simply going to be answered. That to the left of the turning point, x value, and to the right of the turning point's x value, we've got gradients that are negative. And so clearly, I'm going to explain this as x being less than -1/3 or x being more than 2. And obviously, if you'd have got these values wrong, they would then continue accuracy mark in this particular question. Okay, that's about 26 marks, so about 18% of your paper 1 in the bag. So if you can do all of those things, x cuts, y cuts, turning points, point of inflection, know when your gradient is positive and negative, I can guarantee you that you're going to get all of those marks. Okay, so we're going to move on to the next slide, and we're going to do a little bit of analytical geometry. Now, analytical geometry, of course, in grade 10 and 11 focuses basically on midpoint and distance and all those kinds of things. And in grade 12, it's really all about tangents, all right? And also about circles which are centered, circles which are centered off of the origin, and so they are normally of the form x minus a squared plus y minus b squared. Gosh, isn't that terrible? We make a mistake. X minus a squared plus y minus b squared is equal to r squared. Now, this is not such a difficult question. It looks quite difficult, but it's really one of those questions where if you just go with what you know, you'll be fine. So AC is a tangent to the circle with the center 0, 0. So in fact, we're back with our old circle centered at the origin, and they're giving me that this thing here is a tangent. Then they are telling me, prove that the equation of the tangent going through the point AB, so let's just make that a little bit clearer, that this point here is the point AB. They want me to prove that it will be this equation, by plus ax minus r squared is equal to 0. Show all the relevant calculations. Now you can see again, I've chosen a question that says show, which is the same as prove, and you cannot use this and work backwards. You've got to actually assume that they said, all right, find the equation of the tangent, and then you've just got the answer to refer to. Okay, so guys, let's go with what we know. We've got a tangent, so we know that the gradient of a tangent is equal to the negative upside down of the gradient of the radius. Okay? So in other words, when you multiply their two gradients, the answer must be -1. So the gradient of the tangent multiplied by the gradient of the radius must come to -1. The reason for that is because that angle created at the intersection or the point of contact is a 90-degree angle. Okay, so let's start with what we know. We know that the gradient of the radius, all right, look at the picture. Remember, our gradient is y2 minus y1 over x2 minus x1. Now we know that this is the point 0, 0. So our gradient is going to be b minus 0 over a minus 0. Okay? So it's definitely going to be b over a. Therefore, the gradient of your tangent is definitely going to be, turn this upside down, we're going to get a over b, and change the sign. Okay? Now that's grade 10 stuff. That's not difficult. So what do they want us to do? They want us to get the equation of the tangent. So my immediate response is to say, fine, my tangent is a straight line. Okay, so my tangent must be of the form y equals mx plus c. Okay, everybody got that? Now, what do I know about the gradient of my tangent? Well, very definitely the gradient of my tangent is going to be minus a over b, all right, x add c. Now, if I have a look at that, all right, does it look anything like what I am trying to prove? Well, no, not yet. Let's have a look at how I could bully this to see if I could get it anywhere close. So if I got a common denominator of b, I would get by is equal to negative ax, all right, and then plus, what else would I would get? I would get a bc. Okay, so at the moment I'm really battling to make it the same as what they had. Okay, so what am I going to do? I'm going to go back to where I started off and see if there's any other information that I could use. Now, I don't know if you remember from my calculus question earlier, I said to you that one of the most powerful things about a point is that if you know it lies on a line, you can sub it in. Okay? So let's go and see what happens if we sub it in. So for the moment, I'm going to just take this away because it didn't get us to where we needed to get to. And we are now going to do the most reasonable thing, which is to sub in the point AB, because it lies on the tangent. Right. So that means that what we are now going to have is B is equal to, okay, negative A, the x value is A, over B, add C. Okay? Now, at this point in time, I'm now going to need to find C. Can you see that from the original thing, I'm missing this piece of information? The r squared is what I'm missing. Okay? So let's have a look from the picture if I know how to get my C. Okay? All right, can we just go to a quick break? I think I've got a problem.
Okay, let's just go for a break. And while Heather makes this question look even more exciting for you guys, we'll see you shortly.